Hi, hello, vanakkam, and welcome to Little's Law YouTube channel. So far in our videos, we are seeing about various client-side performance testing and performance engineering metrics and tools that we are using. So today in this video, we are going to see about the first performance audit opportunity, so which we will use to improve the performance or to stop increasing the response times. So the first opportunities which we are going to see as part of this client-side performance testing video is eliminating the render blocking resources. And before we move on to this video, I believe you would have seen about our previous videos on the introduction to client-side performance testing, introduction to Lighthouse, and how to see or what are all the various performance, the client-side performance metrics. So before we move on, this is me, Vasan Shanmugam, and I welcome you all to Little's Law YouTube channel. Please do subscribe to our channel if you have not subscribed yet. So the first opportunity, as I told you, is eliminating render blocking resources, and that is the first opportunity that we're going to see today, and that is the only one that we're going to discuss today in this video. And before that, I have the website opened here, and I have indianexpress.com, which we are going to check, and we have this eliminate render blocking resources here. So we'll see what is this and how do we fix, or what are all the various opportunities to fix it so that we get a better performance. And before that, so here we could see the performance of this particular website is 57, and we could see the first contextual paint is 0.9 seconds, and the time to interactive is 5 seconds. The speed index is 1.9 second. The total blocking time is 860 milliseconds. The largest contentful paint is 1.3 second, and the cumulative layout shift is 0.114. And most of the metrics that we see here are in amber or in red, and only the first contentful paint is in 0.9 seconds. And the main reason that you can see that most of the client-side metrics were in poor performance is because this particular website is hosted in a different region, and I'm testing this particular, or I'm trying to access this in a different region. And since I do not have any of these servers hosted near to my location, so that is the main reason where the latency has increased, and that is the main reason for the poor performance of this application. So this is why most of the application providers host the the applications or the website, the content in all the geographies if they are being distributed in different geographies. First opportunity, which is the eliminate render blocking resources. And the first thing is, let's see what is this eliminate render blocking resources and how does this helps us to improve the performance. So the opportunities section of the Lighthouse reports lists all the URLs which blocks the first paint of our page. So if we can see here, so we can see the audit relevance to this FCP, which is the first contentful paint. So this shows, which means this particular audit is mainly because of this eliminating render blocking resources and reducing unused CSS. And if we go to TBT, which is the total blocking time, so when it comes to total blocking time, the eliminate render blocking resources is not part of it, so that is why we cannot see that here. So, and for this total blocking time, we could see avoid serving legacy JavaScript to modern browsers. You will see them on our opportunities on how to fix that. And when it comes to the LCP, which is the largest contentful paint, again we have this eliminate render blocking resources, reduce unused JavaScript, and reduce unused CSS. And when it comes to CLS, which is the cumulative layout shift, where the layout will get shift whenever we click on any item or whenever any new data feed comes in. And for that, again particularly, we don't see the eliminate render blocking resources, and this image elements do not have explicit width and height, and avoid large layout shift comes into picture. So we can see here for the FCP and for the LCP, we could see this eliminate render blocking resources. So the goal of this particular eliminate render blocking resources is to reduce the impact of these render blocking URLs. So here we can see these URLs, and by inlining these critical resources, or by differing these non-critical resources, or by removing anything which is unused. So these three options we have. So the first option is to inlining critical resources. The second one is differing non-critical resources, and the third one comes with removing anything unused. So these are the three ways where we can improve the performance through this eliminate render blocking. So we have to find the critical resources, and we have to find the non-critical resources, and we have to find which is not used. So by using this eliminate render blocking resource, we can find all these three resources and we can eliminate them. So let's move on to the next area. So here we can see, so these are the URLs which is taking more time or blocking the first content of the page. So this is the CSS of this particular URL, and then we have the other URL which is the JS. So Lighthouse basically flags two types of render blocking URLs. One is through the styles sheets, which is the CSS, and the second is the scripts, which is the JS. And here we can see we have a CSS and then we have a JS file. So any script that is in the head, or that does not have a differ attribute, or that does not have an async attribute. So whenever a script tag that is in the head document without the differ and the async attribute, so whenever they lack, they will be a reason, the primary reason for this to take a lot of, or which takes more amount of performance time to get covered. And then when it comes to the other tag, which is the link rel related to the style sheet, so anything that does not have the disabled attribute. So why do we need this disabled attribute? So this disabled attribute, when this attribute is present, the browser does not download the style sheet, which in fact saves a lot of data and saves a lot of time, so that the page will load very quick. And any of the tags which does not have this media attribute, so anything that matches this attribute where the user's devices specifically, is considered a render blocking. So these two attributes, which is the disabled attribute and this media attribute, participates in increasing the response time. So how to identify these critical resources? So the first step to reducing the impact of render blocking resources is to identify what is critical and what is not critical, and for that we can use the coverage tab in the Chrome Dev tool to identify the non-critical CSS and the non-critical JS. And when we load or run the page, the tab tells us how much code was used and also how much data and how much was loaded. And we can reduce the size of the pages by only shipping the code and styles that we need, and by clicking on the URL we can inspect that file in the source panel, and the styles in the CSS files, and code in JavaScript files, and we can mark in two colors. So for that, initially you do not have this, so just click on this three dots and choose coverage, so you get this coverage, and now click on record button, and here we can get all the CSS, all the style sheets and the scripts files. And when you can see here, 80% of this data is unused, and we can clearly see here that the red color are non-critical, and these are the styles that apply to content, but they do not immediately, they are not immediately visible, and the code do not being used in the page core functionality. And anything which is in the green are the one that which are required for first paint, and these are critical to the page score functionality. And here we can see 96% of this particular css were not used or were not required for the first paint, and 100% of this css is not been required or it's not been used, and 98.2% of this particular JS file is not been 98.2. Again, it's like too much of resource is being unused. And again with this Chrome Web Data, and 96.5% of this particular CSS file is not being used. Same way 100% of this particular CSS, and the most commonly used were the 65% and 57%, which are the two CSS which are at the bottom. So here we can easily identify which is not used or which is not required, and which is the most important files that we require for the page. So now we have identified the critical code. So what we have to do now is to move that code from the render blocking URL to an inline tag in the HTML page. So when the page loads, this will have what it needs to handle the page core functionality. So again, let me just give it. So what we have to move is we have to move this to the inline script, and by doing this we can avoid these files to be loaded during the page loading, and this, since this do not handle the page score functionality. And if there is a code in the render blocking URL which is not critical, we can keep it in the URL and then mark the URL with the async. So we have seen already, by using the async or by using the defer, we can make them to avoid the render blocking, and since they were not critical. So how to eliminate the render blocking style sheet? So here we can see a lot of style sheets are being used in the pages now. So how to eliminate these render blocking style sheets? So similar to inlining code in script tag, so we have seen in the previous one, so the inline script. So similar to that, the inline critical styles required for the first paint inside a style block at the head of the HTML page. So similar to this inline, so we have this style block at the head of the HTML page. So by loading the rest of the styles asynchronously using the preload link, so we have to use the inline script and then we have to use this async. So what we have to do is, like, we have to move these files to this particular inline script so they won't load it in the very beginning. Otherwise we can keep it inside the async so that the loading of these styles happens asynchronously using the preload link. So we can even consider automating the process of extracting and inlining the CSS using critical tool. So this is the page for this critical tool where we can use this, we can install it, and we can use this to handle this issue. So I will just paste this link in the description for you to just check it out. And then there are various other approaches, and one of them is to eliminate the render blocking styles by splitting up those styles into different files where we can organize them by the media query. So by splitting the files through media query, we can even eliminate the render blocking styles, and by even adding a media attribute to each style sheet link, and when loading a page, the browser only blocks the first pane to retrieve the style sheets that matches the user's device. And finally, we will want to minify the CSS to remove any extra white space or character. So we'll see that minifying CSS, how to use that in a separate video. So for now, so far we have seen on the very critical thing, that is the eliminating render blocking resources. So there are three attributes, which is the inlining critical resources, or deferring non-critical resources, or removing anything which is unused. And we basically have these style sheets and the scripts with the CSS and the JS files, and we have options to either defer the non-critical resources, or we will have to bring the critical resources under the async tab, async attribute, so that they will not take much time to load for the first contentful paint. And then we have the options to link her relative to the style sheets, where we can disable the non-critical resources, and then we can use this media attribute, and then we can use this inline script as we have discussed earlier. So with that, we come to an end, and I believe this video would have been very useful to you. So until we meet you in another interesting video, it's bye bye from Vasan Shanmugam and Little Slaw.